Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on our system designing fundamental playlist. And the video or the topic that we will be discussing today is called as the scaling. So before we jump into what is the scaling, what are the different type of scaling and all these things, let's first understand that the real use case that why we actually need scaling, because this scaling is nothing but a solution to a problem. So let's first understand that what is the problem that we are talking about. So if you have remembered in our last video when we were discussing about the network protocol, at that time at the very end I was telling you or giving you a small example of the scaling. So in this video we will go inside that concept and we will try to understand in detail that what was the actual problem the user will be facing if we do not do the scaling for a particular service. So the first and foremost thing, let's understand this problem statement with the help of a simple analogy. So let's take an example that you are a college student and for your final year project you have created an application called as a PDF editor, which you have powered with some AI intelligence like GPT or something, so that whenever a particular user upload a PDF document in your website, they will get a summarized view of the entire PDF with the help of the AI. And not only that, you are also giving the provision to edit the PDFs online, to merge two or more PDFs. So your application actually deals with a complete PDF solution where you can provide any PDF document, and based on whatever the use case you need, you will be giving some solution. So that is a problem statement or a project that you got in your college project, and somehow you have managed to implement the entire solution and it is working very efficiently in your local machine. But since you have to present it to your teacher, so obviously you need to host it somewhere or you have to deploy it into some server so that every teachers can go through your application and can give the feedback and the remarks accordingly. So what you did? So here, for example, you have created an application called as the PDF editor, and this editor does everything regarding PDF, starting from the scanning of the PDF, analyzing the PDF, editing, and all these things. So this is nothing but your application, and since you have to publish this software and you have to deploy it somewhere, so what you did, you went to the AWS platform or any of the hosting platform and you bought a simple server from their end, and on top of that server you have hosted your entire application. So this is nothing but your server where the entire solution of this PDF editor is hosted. I hope this is clear. And similarly, you have a client application deployed also in an Amazon server. So this is your client application. I hope this is clear. So whenever a client or the user is uploading a PDF in your application, the front end is sending the request to our backend, means to our server. There all the processing is happening, means scanning of the documents, tokenization and everything regarding the AI. And once the solution is done, means once the concise version of the PDF or you got the solution, you are sending the response to the client. I hope the use case is clear. Now, since you have integrated an AI model into your solution, so as you know, the AI is a bit slower because there are a lot of computation that actually happens in the backend. So let's take an example as a ballpark number. The total amount of space that is required to compute a PDF file is around 25 MB. So for example, anyone can upload a PDF of any size. It can be a 10 MB file, it can be 50 MB file or whatsoever. But let's take an average number like 25 MB of space is needed on the server cache to run any of the computation. Clear? And let's take an example. This entire process takes around 10 to 15 seconds. So after 10 to 15 seconds, you will get your result. So this is how you have developed your application. So these are nothing but some of the stats or the latency by which you can define your application. Now, once you have chosen the server from the AWS or any of the hosting platform, you have choose the smallest and the most cheapest server that was available. And let's take an example that the server that you choose have this configuration, means it is a small server and it have 8 GB of RAM. So whenever you are actually buying a server online or buying a compute from the online for the cloud hosting, there we have some specification mentioned for the server, means it will define that how much GB of RAM is there, what is the CPU and the GPU power. So all this configuration will be mentioned in the specs, and since you do not have the budget, so you have opted for the least server that was available, and on this server you have deployed your application. Now understand this point clearly. So you have shared the URL where the application is hosted to your 20 professor. Now what the professor will be doing? All the 20 professor, let's take an example, want to validate or test your application. So all the 20 professor have hit your URL at the same time and have uploaded the PDF file of different size just to play around with your application. And let's take an example, the average size of the PDF is also 25 MB. Now since 20 professor is actually doing a computation or processing their data together, so the total amount of space that is needed in your server backend is 500 MB, which is far below the total capacity of the server where we have deployed our application, because our application is deployed on the server which have 5 GB of RAM. But since we only need 500 MB of RAM, so for this use case, we do not face any problem. All our professors are very much happy with the processing speed of our application and how we have done all this analysis or we have created the project. I hope this is clear. Now let's take an example that since your professor is very much happy with whatever you have delivered, since you have integrated AI in all these things, so what they want to do, they want to showcase your project to a much bigger audience. So what they decided that on a particular event day, they will be showcasing your project to all the computer science department at your college. And let's take an example that your CS department or the computer science department have 300 students who are ready to test your application. So what they did, all of a sudden everyone jumped into your application or jumped into your website to test what you have created. So what will happen, all the 300 students that you have in your class will start requesting or start uploading their PDF file into your backend server. And here, if you look carefully, right now the computation actually got changed critically, because right now the total amount of memory that is required over here is nothing but 25 into 300, which lands up to 7.5 GB. Though it is less than the total amount of the server size that you have, but you will face a lot of complaint from your fellow mates, because whenever a particular server reaches a threshold or reaches a maximum capacity, there will be lot of requests that will get timed out, because obviously you cannot say that all the requests will get fulfilled within 10 to 15 seconds. It might can happen that some have uploaded a huge document which is taking more than 15 to 20 seconds, or someone have intentionally uploaded a file that is huge, maybe it is more than 100 MB. So you cannot say every time that whatever the request server get, it will get resolved within this timeline or within this time frame. So there will be always a latency in the processing speed depending on the file size your user is uploading. And since you have already reached the threshold, the maximum threshold or the maximum capacity of the server, so lot of user will be facing the timeout exception, or they will be seeing the processing speed of the server decreases significantly. So obviously at that time everyone will be complaining you that your application is not good and it is not giving a response within a particular timeline. So it will be a very bad user experience. So to resolve this issue, you have to think something else, means how we can solve this problem, because right now your application is only used by 300 students. Now in the next month, whenever it will get presented to the entire college, all the 1,000 students might be using your application at the same time. Now if your application is not able to handle only the 300 number of students, so obviously it is not possible for your application to handle that much amount of the traffic. And to get the solution, you went to a senior of your college. So the basic solution to this problem which your senior will provide, he will tell it's better you increase the server size on which you have deployed your application. So if initially what you did, you deployed in a small server, that is a T3 server which have a RAM of 8 GB. Now for the demo purpose, what you do, you go for a larger server which might have 32 GB of RAM. So now you again went to AWS store. Here you will see that there are multiple variants of server which are available over there. And since at the very initial state you have to just submit the prototype, at that time you have taken the least possible configuration that was possible. But right now you have seen that and you have understand that why you need a bigger server, because the amount of the customer or the user have increased for you. Now what you see that over there are three different types of server that are available. Let's take an example. These are the three different variants of the server that are available over the portal. So initially you have opted for the smaller version which cost you $60 per month. So this is just a ballpark number I'm giving. Now since you need a bigger server, you can see that there are two variants of the server that are available. One is the medium size which have 32 GB of RAM, and there is a larger size which have 128 GB of RAM. So there are two more variants of server that are available which might can fulfill your problem statement, that is to support the application for the entire college where you will be presenting your solution. But on the back of mind, since you already know that this is a constraint, that it uses 25 MB of RAM and 10 to 15 seconds to process a particular request, so you are thinking that if my college have 1000 students, means if I have to fulfill all this request, means the total number of RAM that we need over here is nothing but 25 GB, which fits your requirement of taking a medium sized server. So if you just upgrade your server from a smaller one to a medium sized server by paying this much extra, all the college students who are there at your college can use your application without any problem, because this is quite below the total RAM that is available on this server. So you have upgraded to the next solution, that is the medium sized server. Now right now all the students in your college are completely able to use your application without any delay or timeout. So it fulfill all your needs. So here if you have seen that what we did to facilitate or fulfill more number of requests or more number of user, we have increased the specification of the server, means we have gone from a smaller server into a bigger one, and this is nothing but what we call as the scaling, means we are scaling our server to one level to another. And since here what you did, you have increased the capacity of the server from a smaller one to a bigger one, means you are upgrading the server capability, and that is why this type of scaling is nothing but what we call it as a vertical scaling. So I hope this is clear that what is the example of the vertical scaling. Means whenever there is a requirement that you have to fulfill more number of user or your application, the first brute force solution that you can think of is increase the size of the server so that all this computation and all these things can be fulfilled, and this type of solution is called as the vertical scaling. But here if you look carefully, there is a problem with this solution. That is, though at this time it is fulfilling all the 1000 requests of the students of your college, but in future if you want to start a business with this solution or you want to launch it as a product across different college, at that time again you will be facing the same type of issue, because with the growing number of students you have to keep on increasing the server size accordingly. So for example, right now you are fulfilled with this medium size capability, but obviously this server also have a threshold or also have a upper limit, and if you do a basic calculation with this estimation, though it is not done in this way, but I'm just giving you a ballpark idea that if you do with this type of assumption or this type of calculation, you will see that the total number of requests this medium size server can facilitate or fulfill for your application is around 1200 requests per second. Means if it goes beyond 1200, means the total number of size or the RAM that is required by your application will be beyond the capacity of this server, means again your server or the application will be down and your client will be facing the timeout issue. Means whatever the solution you are providing is not at all flexible with the growing amount of the customer. So the maximum possible solution that you can do, you can just opt for the maximum or the largest possible server that is available, that is 128 GB server, but you will see that the cost of acquiring it is very high, and obviously this server will have a top limit of the total number of requests it can process. So by this method of vertical scaling, whatever the server you choose, there will be a upper bound till which it can scale or it can support the total number of users. And also there is one more important thing that you have to consider, that since these are nothing but the servers, these are actually running on a hardware, and so each and every hardware have a finite amount of the limitation and everything. It cannot happen that your server will have infinite amount of GPU or RAM. It is practically not possible. So this way of vertical scaling can fulfill your requirement till some point if your business or your application or the product fulfill only a handful number of customers or the user. But if you are thinking of taking the product globally where millions or millions of requests will be coming into your server, then this process of scaling is not at all a good solution. And also remember one thing, whenever you are scaling an application or whenever you are deploying an application, at that time you also have to consider one more important thing for this calculation. That is, at any point it is a convention that we normally follow, that we only utilize the 70 to 80% of the server capacity. Means even if your server is capable enough to support 128 GB of RAM, but we take 80% into consideration, which is nothing but around 100 GB. So though on paper you have 128 GB, but it is a convention that you only allow max to max 70 to 80% of the total server size. And the reason behind that, it might can happen that some user is uploading a huge document or anything into your application, and your application went into some infinite loop or it went into some exception. So at that time, to recover from exception, we have to give the server that amount of space so that it can process all those spikes or all those heavy traffic accordingly. So on a very high level, if you have understood it correctly, that though the vertical scaling is a very good choice, but it has some limitation. That is, the vertical scaling is not possible to an infinite amount of time. But right now, since you have already acquired the largest possible server from the AWS client, what next? How you can scale or how you will support, for example, 2000 or 3000 clients together. So the next solution to this problem is what we call it as a horizontal scaling. So what we do in case of the horizontal scaling, we do the same way what we have done over here. But the only difference here is like, instead of just deploying our application to a single server, we deploy it to multiple servers. So for example, this is server 1, this is server 2, and right now if you think it logically, all the three of them have the same application that you have created, and all of them will have separate GPU and CPU. Means here if you look carefully, for each and every compute or each and every server, it will be having this amount of the RAM. Means for example, you are going with a medium size server, so this server will have 32 GB of RAM, this will be having 32 GB of RAM, again this will be having a 32 GB of RAM. And what we are doing right now, whenever a particular server is over fulfilled with the request, means for example it went to 80% of the total amount of the request that it can sustain, after that what we do, we divert the traffic to our next server, means this server which is right now untouched. So you can easily understand that whenever this server have reached the 80% threshold, we have moved to our next server. Again, if this server also went to a 80% threshold, then what we will do, again we will send our request or send the client request to our third server, and in this way, based on the server capability, we will be distributing the traffic across all the servers so that none of the server get overloaded and none of the request gets timed out for the client. I hope this is clear that what is a horizontal scaling. So here what we are doing, taking the same server over here, we are doing a multiple replication of the server, means we are deploying the same application into different server, and we are routing the client traffic across different server, so that based on the usage of the CPU or the usage of the server, we will divert the traffic accordingly to different servers that we have configured in the backend. I hope this is clear. But if you look carefully, we have not done anything about the optimizing the solution or optimizing the application, because here also each an application is taking 25 MB of memory and it is taking 10 to 15 seconds to process. So the application still remains the same, but how we are handling the traffic or how we are enhancing the hardware is actually changing. So this way of increasing the server capability is known as the horizontal scaling. I hope this is clear that what is the difference between the vertical scaling and the horizontal scaling. So here if you understand this, scaling is the way of increasing the server capability to fulfill the request of the user, and the two ways by which we can scale a particular server is with the help of number one, the vertical scaling, and number two, the horizontal scaling. Now here if you look carefully and understand the scenario, what is the advantage of doing the horizontal scaling over the vertical scaling? Let's first understand this problem. So the problem of this vertical scaling was the server size. So there is a fixed threshold or the fixed configuration or the fixed number till which you can scale your server. Beyond that, it is not possible to scale even more because this is a hardware constraint that you have to keep in mind. But in case of the horizontal scaling, there can be n number of servers replication you can provide in the backend. For example, with the 3 server, if right now we can provide 1200 customers or 1200 users right now, if in the future 2000 user comes to use our application, we do not have to increase the size of the server. Rather, what we will do, we will do the horizontal scaling, means we will increase the number of instances on which our client is actually deployed. And in this way, the future also, it will be a flexible solution that even though there are thousands requests are coming into your business, you just need to add few more replication of the server so that all the requests get fulfilled at the backend. And one more important thing, and one of the major important thing, that is here if you look carefully in the vertical scaling, what you did that your entire application was deployed in this single server. Now in case any of the user just upload a malicious file, or in case by anyhow your server gets into an error handling or gets into a restart, then entire of your application will be down, since you have a single point of failure over here. So the major problem with the vertical scaling is the single point of failure, means you have the deployment only on the single solution, on means only on a single server, and if the single server fail, your entire application or entire product is down. But in case of the horizontal scaling, even if a particular user or a particular client sends a malicious data or a malicious file to a specific server, this server might be down, but still you have these 3 server left, so that no other request from other clients will get timed out and your solution will be available all the time. So you can easily understand that horizontal solution is much more feasible and more user friendly approach than that of the vertical scaling. So I hope you are completely clear with what is the difference between this entire horizontal scaling as well as the vertical scaling. Now I will give you a small demo of this entire vertical and the horizontal scaling, which I will be hosting into my website, so that it will be very easy for you to understand everything. So here if you see and look carefully, this example is also showing the same thing that I have explained you right now. That is, for example, multiple clients are requesting or sending the data or sending the request into your server, and within a few moments, since your CPU is overwhelmed with the data or the request, your server is actually getting crashed. So this is your problem statement. And to solve this problem, what we did, the first approach is the vertical scaling, means we are increasing the size of the server, and you can see right now more number of user requests is getting fulfilled. But still there is a constraint that there is a fixed amount of bandwidth till which we can increase our server size, and if that size is also fulfilled, then there is no possibility by which you can do scaling even further. So the last and the second solution that you have, that is called the horizontal scaling, where we are distributing the traffic uniformly across different servers based on their availability or based on the CPU usage that we have over here. I hope you are completely clear with what is the scaling and what is the difference between the horizontal scaling and the vertical scaling, and to solve which problem statement you will be implementing which solution. Now if you have seen over here, there is one more problem that I have generated by introducing many servers into our application. So here if you look carefully, we have 4 servers over here to fulfill our request. Now whenever we are increasing more number of servers, which means that IP address of the server will also change, because as we have discussed earlier, for each and every server that we have, each server can be uniquely identified on the internet with the help of an IP address. Now let's take an example. This is the IP address of this server. This is the next IP address of this server, and so on. So here if you look carefully, the IP address is getting changed with each and every server that we are introducing over here. Now, if you have remembered in the DNS video, what we have told, that the solution that the DNS provide is like it converts the domain name into an IP address, means it does the resolution of a user-friendly domain name into an IP address, so that we can uniquely identify that for this domain name, which is the backend system that is there. So initially, since there was only one server, we have not faced any problem because it was a static server IP. And similarly in the vertical scaling also, since there was only one server and we are just increasing the capacity, but the IP address was fixed. So we have not faced this problem of getting the application deployed in multiple IP address. So with the introduction of this horizontal scaling, we have came up with this new problem that for this domain name, somehow we have to map this request into 4 IP or the 4 servers that we have configured in the backend. But as you know, a particular domain name can be associated with a single IP only, so it is practically not possible that each client will hit different URL or different IP to fulfill their use case. So to provide the solution to this problem statement, we came up with another solution, and that is nothing but a load balancer. So here what we will do, here we will introduce a magic box which actually fulfill the problem that we were facing over here. That is, here we will introduce a service in the middle which we will call it as a load balancer. And what this load balancer does, that is, it is this black box which solves the problem of diverting or routing the traffic among all the 4 servers. So for the client, it is still the single IP, that is the domain name IP. So your client will hit this black box or hit this load balancer with that IP only, but internally this load balancer will be responsible to route all the requests among all the backend servers that are deployed or got introduced due to this horizontal scaling. So it is completely responsibility of this load balancer that how it will route this traffic among all this newly introduced server in the backend. I hope you got the idea or the concept that why we need a load balancer over here, and what is this load balancer, how it works, what are the algorithms that are involved, how it divert or route the traffic into different servers. Everything we will be discussing in our next video, where we will see in detail that how our load balancer actually works. So see you in our next video, where we will be seeing that what is a load balancer and how internally a load balancer actually works. But before that, if you have liked this video and if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you in our next video. Thank you.